Let's look at how the Unreal Engine handles strings and text. For that, though, let's review just strings in general in C++. So we can have a char star, or char star, which is a C-style string. This is just effectively a character array that ends in a null terminator. There are helper functions to read that string, looking for the null terminator, like strlen. And we can see here that there are 5 characters in this string. And each character has a size of 1, which means it is 1 byte. So this is a character of about 5 bytes. There's also wide characters, and we can get a string array of that by prefixing it with L. And there is a WCSlen for getting the length of that. You can see that there's 5 characters here. The difference is that the wide character size is 2 bytes on this machine, and the character size is 1 byte on this machine. In C++, there is the std_string, which you can assign to it just a C-string, and it wraps that and manages that. And there's also the wstring class in the standard template library for wstrings. Again, prefixed with an L, and it's able to manage and wrap that. So in Unreal, we have this concept of TCHAR, and it's similar to this wchar array, but it's a bit abstracted. And instead of using the raw char array or a wchar array, you use this tchar instead. And to get an appropriate one, you use this text macro and wrap your C-string in that. And there's 2 documentations you can read about this that are very good. The first is on string handling and goes over what we're about to cover a bit. And at the bottom, it tells you that you should be using the text macro when setting string variable literals. If you do not specify the text macro, your literal will be encoded using ANSI, which is highly limited in what the characters it supports. Any ANSI literals being passed to FString need to undergo a conversion to TCHAR, native Unicode coding, so it is more efficient to just use text. So this is why you should be using text, at least with FString. There's also this text encoding documentation you could read and understand a bit deeper as to what the encodings are doing. But for practical purposes, just use a tchar array, and you actually very rarely have one of these raw like this, mainly using this text macro to generate your strings. And so if we mouse over that tchar array, you can see that it is a wide string tchar array by that L prefix. So, like std_string, Unreal has an FString, and you initialize it using that text macro and then some literal. So here I initialize my FString, and then I make a second FString. You can do things like string comparisons, which can be slow. So, in gameplay logic, you may not be wanting to actually compare raw FStrings, because these are like fully managed strings in that it's managing an array, has to walk potentially over each individual element. So if we do this comparison, probably first it's going to do a len check, so make sure they're the same length, and if they're not, then they're not the same, but if they are, then it likely has to go over each character and make sure they match. I haven't actually looked at the equals operator, but I assume that's what it's doing, or something akin to that. So if we actually go to the definition of that, it looks like it's actually doing a wide character string comparison. FString, it talks about how it can be modified in comparison to strings. However, these make FStrings more expensive than immutable string classes because they store their own character arrays. So you can compare them that way. And then here I initialize a third string, and I compare that with the first string, which they no longer equal. So you can see that the equals works for strings. You can run this function to get the length of the string. There is a concept of string views that can be initialized to a string and pass around the view instead of the mutable string, similar to the array view. You can format a string using the printf function. Here we have a float that has 0.2 specifier, %f, and an int with just a %i, and we pass in a float and a 2. And if I mouse over that, you can see that it has float is equal to 1.00 and int is equal to 2. So FStrings are good for kind of string manipulation type of logic, should you actually need that. I think I primarily use it for debugging mostly. What I use more is the FName class, and this is a fast string. As I understand it, the FName strings have a table that back them, and it ends up using indices. So if you make a new string, it gets a new entry in that table, and the documentation says they're case sensitive and they're immutable. So here I make 2 FNames, which are a string, and I can compare them, and they are equal. In the name type stage, it does look like the operator equals is using an int comparison, at least for this version. There are quite a few equals operators. And so comparing 2 FNames should be much faster, as it should be an index comparison rather than a per character basis comparison. So it's not having to compare each individual character between the strings. It's instead comparing the indices of the tables where the string got stored. Documentation says they're a lightweight type, efficient for string handling, refers to the table and the number that the string is referenced by. It's fast to convert a string to FName, but perhaps not as fast as just using FNames from the beginning. They're useful for object names, identifiers, and other strings that are frequently compared. But once they're made, they're immutable and they are case sensitive and cannot be manipulated. You are able to create a FString from an FName. So we can get back to that per character array version. The other major string class is FText, and this is for user-facing text that may need translation, or more formally known as localization. And so you need to be careful converting an FString to an FText, because likely you're writing your code in English, but the game that's running may not be in English. So you need to take special care for creating FText to make sure the user-facing strings are correct. In case you've never heard of localization, it's sort of like translation, but I'm not an expert on it, so there's perhaps more to it. Basically, you set it up this way if you want it to be translatable or localizable. So even in English, there are different localizations. So you have American English and then United Kingdom English, where there's different spelling and stuff. Maybe that's why it's called localization rather than translation. But nevertheless, what you want to do is use this NSLOCTEXT macro. It has a namespace first, so this is kind of like a category. You don't really see this, but I think it helps for people that are translating. And then a name, and then the actual string. So if we look at that macro, you can see it has an in namespace, a key within that namespace, and then the actual text. So this is the namespace, here's the key in this namespace, and then here's the text that would be translated. So this is a user-facing text, and this should initialize to something else if you're in another language. So it depends on your locale that you've set it to. So for example, here we want a greeting. We'll default it to hello in English. We'll put it under the title screen namespace, and we'll say it's a greeting. So while it's hello here for us in English, if they were using the French locale, it may be bonjour. There's also another macro to NSLOCTEXT. It is a namespace version, so you have this define LOCTEXT namespace, and then you undefine it. So this is the namespace for title screen that we used up here. And now you can just use the LOCTEXT macro and give it the key and the namespace, and then the string you want it to be. So press play to start. And for exit, we have another one, exit prompt, and some text, so you sure you want to exit. And these are both under this LOCTEXT namespace. Because people need to actually translate and set up other localizations, you need to take care for formatting, and there's an FText for format. So here we're going to say the NSLOCTEXT, since we're out of this namespace, we're going to use the NSLOCTEXT version of the macro. Title screen is the namespace, the key is going to be score display, and then we'll say high score, your score is blank, highest score is another blank, or effectively 0 and 1. And then you can format a number as FText, because there's different number locales. For example, in the US, we put a comma before the 1000, and I believe in other locales, they put periods there. So you format the number appropriately for the locale, and this FText format is able to insert it there. There's also another version of this format that's a little more helpful to whoever is actually doing the translation here. You can set up this format arguments and give it some names, the current score and high score. We're going to set 100 into the current score and 1000 into the highest score. And then we'll use the FText format again with the NSLOCTEXT under the namespace title screen with the key score display. And again, we'll say your highest score is, and this time we'll say current score, new line, and then the highest score is highest score. And we pass in the args, and it's able to read from this. And the reason this one is more helpful is that the person that's translating this can see your score is current score and perhaps infer how this should be localized. And the same thing with this other line here. And if we inspect the FText, you can see there is the string there. Same thing with this one. And you can compare FText with the equal to method. And we can see that these two FTexts are in fact equal. If you do need to log it, you can convert an FText to a string and then convert that to a TCHAR array and pass that into the %s of a log and get it logged. Here it is logged. You can see that our new line seems to have worked because we have a new line here and it puts the second line right there. And so that's a really high-level summary of how text works in Unreal. You have this TCHAR array, which is kind of the raw string. Then you have the FString, which is the managed string, where it actually has an array. You have FNamed, which are these hashed strings that are fast to compare against. And then you have FText, which is the text that actually users see and may be localized for their given language or location. So I hope that helps. Let me know if you have any questions, comments, concerns, or even corrections in the comments below. And until next time.